Okay, think about this for a second. What if we could get AI to invent new AI? To break through the limits of our own human creativity and design the next generation of intelligence for us? Now, that might sound like something straight out of science fiction, but it's exactly what we're going to dive into today. So, where is this all coming from? None other than Google DeepMind. The same lab that brought us AlphaGo, the AI that completely conquered the world's most complex board game. Well, now they're tackling an even bigger challenge, teaching AI how to design itself. All right, so to really get this, let's frame the puzzle they were trying to solve. How in the world do you build an AI that can master a game of bluffing, deception, and incomplete information? A game like poker. For decades, the answer was, well, it was us. It relied on human genius. Researchers would use their intuition, they'd run countless experiments, and they would painstakingly tweak these complex algorithms. And look, that approach got us incredibly far. But as AI gets more and more complex, our human intuition is starting to hit a wall. Okay, so here's our game plan. We're going to see exactly why human design is hitting its limits. Then we'll meet the AI inventor that DeepMind created to get past it. After that, we'll look at two genuinely new and kind of weird algorithms it discovered. And we'll wrap up by asking the big question: what does it all mean when our tools start inventing things for us? So first up, the human limit. And the core issue here really is just staggering complexity. The search space for new, better AI algorithms is so unbelievably vast that even the most brilliant human minds can only explore a tiny, tiny fraction of it. We're basically looking for a needle in an infinite haystack. And this slide just lays it out perfectly, right? On the left, that's the old way, the human approach. It's like navigating a giant maze with just a tiny lantern, relying on your gut. It's slow, it's winding. The goal is what's on the right, a system that can see the entire maze at once, finding paths and optimal solutions that a human designer would probably never even stumble upon. Okay, but how do you even know if an AI is any good? How do you score it? Well, the key metric is called exploitability. It's basically a score for how easy it is to beat. A perfect, unbeatable strategy has an exploitability of 0. So for the rest of this explainer, just remember this one thing. Lower is better. 0 is basically God mode. So the big question is, how did DeepMind get around this human bottleneck? Well, they built an AI to do the inventing for them. Let's meet the hero of this story, a system they call AlphaEvolve. So what is AlphaEvolve? At its core, it's an AI system that writes code for other AIs. It's powered by a large language model, and it doesn't just tweak a few settings here and there. No, it rewrites the core DNA of an algorithm. The researchers call this semantic evolution, and it's like instead of just trying to breed a faster horse, you're evolving a brand new species altogether. And the way it works is this really cool and surprisingly simple loop. First, you start with a decent algorithm that a human wrote. Then, the LLM acts as a mutator and just goes to town on the code, rewriting bits and pieces to create new versions. These new AIs are then thrown into the ring and tested against each other. And only the strongest, the best performing code survives to become the parent for the next generation. It's literally survival of the fittest, but for code. Okay, so that's the theory. But did it actually work? Oh yeah, it did. Let's look at the first huge discovery it made. It took this family of algorithms called counterfactual regret minimization. And don't worry, we're just going to call it CFR from now on. And it evolved it into something way, way more powerful. Now, the best way to wrap your head around CFR is this awesome regret journal analogy. Seriously, picture a poker player who, after every single hand, writes down how much they wish they'd made a different move. Over thousands and thousands of hands, that journal becomes a roadmap to a perfect strategy, just by trying to minimize all those past regrets. So what did AlphaEvolve change? The big idea here is a shift from being rigid to being dynamic. Think of the traditional algorithm like a train on a fixed track. It learns at a steady, predetermined pace. The new version, VADCFR, is more like a speedboat on a river. It dynamically adjusts how it learns based on how chaotic or volatile the game currently is. And the way it does this is with some really kind of weird tricks, stuff that human designers just hadn't thought of. First, it actually forgets its past mistakes faster when the game gets chaotic, sort of like a player just shaking off a bad hand. Second, it instantly rewards good moves instead of waiting. And the wildest part? Listen to this. It completely ignores its own learning for the first 500 rounds. It basically treats its early self as an unreliable rookie whose bad habits shouldn't poison its final professional strategy. And you can see the results for yourself. They're pretty stark. This chart shows that final exploitability score we talked about. The AI Discover VAD-CFR is consistently lower, meaning it's just a fundamentally stronger player. In fact, across 10 out of 11 different games, the algorithm invented by an AI was either better than or equal to the best one designed by humans.
But wait, there's more. AlphaEvolve wasn't done yet. It then went and tackled a totally different kind of algorithm. And, you guessed it, made another huge breakthrough.
Okay, so this next group of algorithms is called Policy Space Response Oracles, or just PSRO, and the Champions Training Camp analogy here is just perfect. Instead of training one AI against a single opponent, PSRO builds a whole population, a whole camp of different AI strategies. So a new AI has to learn to beat not just one style, but every style in the camp, which makes it incredibly tough and robust. The problem with the old way of doing this, traditional PSRO, is that it uses a fixed training schedule. The AI-discovered version, Shore PSRO, is way smarter. It uses what's called a dynamic annealing schedule. Think of it like a blacksmith forging a sword. You start with intense, fiery heat to shape the metal broadly, and then you gradually cool it down for fine-tuning and hardening. It starts by exploring wild new ideas, then slowly shifts its focus to perfecting only the best ones. And it pulls this off with 3 really clever features. It uses a hybrid approach, blending a stable learning method with a more aggressive one to get the best of both worlds. It uses that smart annealing schedule we just talked about, and it cleverly uses a totally separate, more stable process just to grade itself, making sure it doesn't get fooled by its own chaotic training. And again, the results just speak for themselves. This chart shows how many training rounds it takes to get to a near-perfect strategy. The AI's version gets there in roughly half the time. That's not just a small improvement, that's a massive leap in efficiency. Okay, so let's take a step back and look at the bigger picture here. We have an AI that can discover new, superior AI algorithms all on its own. What are the broader implications of that? Because this is the key takeaway, right? This research isn't really about making a better poker bot. It's a proof of concept for a whole new way of doing science. We've officially moved from using AI as a tool for analysis to using AI as a partner in discovery, a partner that can explore possibilities far beyond the limits of our own intuition. And no, this isn't about AI taking over and replacing scientists. As the researchers themselves state in the paper, the future is collaborative. It's going to be a blend of human creativity setting the direction and AI-driven tools like this, exploring the possibilities at a scale we've never been able to before. And that leaves us with this final, kind of mind-blowing question. We've just seen an AI invent novel algorithms for games. But what happens when we point the same inventive power at our really big problems? Curing diseases, discovering new materials, modeling climate change. The next great scientific breakthrough might not come from a human mind, but from an AI that it created.